Okay, before we go further, I want to point out that even though irreducible quadratic denominators often lead to arctan, sometimes that won't be the case if you have an appropriate numerator, okay? So I wanted to contrast what we just did with a very similar looking integral, but all of a sudden, the integral is a Calc1 integral because I've adjusted the numerator in the precise way to make a different u substitution work out nicely. So if we were just faced with this problem, we'd still want to start off in the same way, which would be to factor the denominator here. Since we notice that it's, an irreducible. And what do we get? Oops. X plus 3 quantity squared. I'm just looking above up here. Plus a 2, and up here we have x plus 3. Okay, and that means that now after I do my u substitution, then I end up with a very nice integral of a u over u squared plus 2, right? So this one is actually a Calc1 integral. It doesn't require arctan. Why not? Because, well, for one thing, it's not this formula, right? Arctan is for when there's nothing in the numerator. Well, there's only a 1 in the numerator, and the denominator is this sort of u squared thing. So we proceed as we would in Calc1 with a u substitution. Although we've already used up u once, so I'm moving on to w. So let's say w is equal to u squared plus 2, and then dw is equal to 2u du. So that means dw over 2 would be my u du. So this looks like 1 over w and du over 2. dw over 2. All right. And now when we integrate, oh, it's a natural log again. Okay. But anyway, all these irreducible types of quadratic denominators could be, really an arctan if it's really irreducible in the sense that we don't have something nice in the numerator. But sometimes it's basically a linear sort of denominator in disguise. If you look at it from a certain point of view, and the certain point of view would be from this w variable point of view. Anyway, let's substitute back to get our answer right here, just so you can see what it looks like. So w squared is u squared plus 2, and u is x plus 3. Okay, and so notice that what we end up with is actually our original denominator right there. In a natural log. And so it should now be very obvious to you how this happened. If you were to take the derivative of this using the chain rule, you'd take the derivative of the outside, which would put this in the denominator, and then you'd take the derivative of the inside, which would basically make this numerator right